So now, a charged particle moving perpendicular to a magnetic field can be forced into a circular path. So I'll just kind of show you what that looks like right now. And then this is kind of the first half of the lesson. The second half we'll do more like circular motion stuff. Okay, so for number one, I'll just show you kind of in general what we're looking for. So say we have north here and a south pole here. And so draw your magnetic field lines. And say we have a positive particle is being shot into this magnetic field, so it's going up. So say a question we could have for this is, what is the direction of FM initially? Okay, just as it's coming in. Okay, so let's apply our third left-hand rule. So, what type of particle is this? A proton or positive something. So which hand do I use? Right, good. Okay, so that's the first thing that we kind of got to think of. Okay, so we have our right hand. So your finger goes in the direction of the magnetic field. The thumb goes in the direction that the particle is coming up. And so which direction is our force going? Out of the page. Yeah, very good. So either you can use this finger and it's just like it's coming out towards you, so it's out of the page, or if you want to just do all fingers, your palm is facing out, so that's coming out of the page. So according to the third rule, FM is coming out of the page. And if we were to represent that, which symbol would I use? The dot or the X? Can you remember?
Dot.
The dot, very good. So our dot. Yeah. So sometimes when I'm working on these, I just write that at the top of my worksheet. Like I say, okay, X is out, see, I already messed it up. X is in, dot is out. And the way that I remember it is that the dot is like a circle and out has a O in it, which is a circle, you know? Because else I get them mixed up. So I just need to put that at the top of my page. You know how in like Chem 30, you know, I'd be like, just write out okra and write out all of your things, just so you have it organized. Do that for this too. Okay. And then the X has a lines in it, and I has a line in it. You know?
T has lines in it too.
No, just look at the first letter.
There's a dot in there.
I know, I knew you were going to say that. Okay. And then let's just note to ourselves in case we're studying and we don't realize, we don't remember. So note, use right hand because positive particle. So now let's look at, say, an electron as it travels through a magnetic field. So let's say here, I'm going to like kind of take a cross section now, and what would a magnetic field look like if I was looking down? So now here, so this is just a different example. Say this is my magnetic field, and so I'm just going to put a note here. This represents uniform magnetic field moving into the page. So it doesn't show us the magnets that produce this, but we're just told the magnetic field. So say I have an electron right here, and it's shot into the magnetic field at this point. So my question would be, draw the prediction of electron movement through that magnetic field. So let's just work here initially as it comes in. So we have a magnetic field going into the page. So that's your finger, right? Magnetic field. So point it going into the page. So we have our magnetic field going into the page. Now I'm going to have to turn my hand to show that my thumb is giving the direction of the electrons. Okay, but it doesn't matter if it's like this or this, because your fingers are still going into the page, right? So we have our electron going into the page. So which way is it going to be forced to go up? Okay, so as it comes in, it's going to actually be forced upwards. Okay, so that's initially, it's forced upwards. So if the question just asked us which direction is it going to be forced initially, we would say up. Okay, so now let's think about what the electron will do once it's forced upwards. So we still have the magnetic field going into the page, but now our electron is going up. So which way will it be forced? To go this way, right? So now,
How is that
because the X represents in to the page. It's just giving us, like, if here is a magnetic field and we looked on top of it, what would it be doing, going in or out? We don't see the magnets in this represent.
say into the page instead of up?
Pardon me?
So you can say into the page instead of up?
Not for the force. The magnetic field is going into the page, but the magnetic force is pushing up.
So how do you know it's up from just
Why is it
Because my palm is going up.
But your middle finger is going
It could be like this. It's perpendicular to your thumb. I mean, sorry. If it's going in, this is perpendicular. Okay? So it's like it's pointing up. Looks like I'm fingering you right now. It's awkward. Okay?
You're a terrible teacher.
Oh, because I'm doing
Yeah.
that. Okay.
No.
Okay, so let me clarify one more time. If I was doing this from, say, at this point, my index finger points in, my thumb goes this way. Your middle finger, if you do the 1, 2, 3 thing, always goes kind of like straight perpendicular of this one. So it's like this. Okay, so then it's going up. This is so.
Palm always has to be like this.
Yep. You always keep, you should just maybe decide which way you like to do it. So say you like to do the palm, okay? So your palm always faces up, or like, is it always in line with your finger, with your index finger, okay? So if this is going in, your electron's going this way, force is going up, okay? Or like this. So now let's follow here. So say we're going into the page. Now my electron is going that way. Which way is it going to be forced? Down. See that? So now as it goes along, it's going to be forced down. Okay? So that's how it gets a circular motion. As it's moving through, it will experience different forces because of the magnetic field. It's, its velocity is changing because the direction is changing. Even if its speed stays consistent, it will have a change in velocity. Okay? So this is how we can kind of get this circular motion going. Okay? So then if we looked at this, we would be able to note there would be a radius here because it will go in a circular motion. So that green is the answer to that question. Okay, so now you can do